Welcome back, everyone. We're going to be solving LeetCode 733 flood fill. So we're given an image which is represented by an m by n integer grid where the image of the row column ij represents the pixel value of that image. We're also given three integers, sr, sc, and color, and we need to perform a flood fill on the image starting from the pixel image source row source column. And they tell us to perform a flood fill, we need to consider the starting pixel plus any pixels connected forward directionally to the starting pixel. So what we need to do is we're given this middle pixel in example 1. Essentially what we're going to do is perform a breadth first search to find all of the pixels that are forward directionally connected to this one. In this case, it would be this one right here and then this one. And then we would continue our breadth first search looking for pixels of the number 1 that are forward directionally connected to this pixel and this pixel. In this case, it would be this one, and then this one here. Right, so then whenever we hit a 0, right, and we can't go any further in our breadth first search, we terminate. So I know we've been doing a lot of medium problems lately, but and this is an easy problem, but it's pretty relevant to solving grid style breadth first or depth first problems, and it's really similar to the count number of islands. So we're going to do it. Like I said, we're going to do breadth first, so we are going to import our DQ from collections. Okay, let's set that up. We will make it equal to Q is equal to DQ. And on this Q, they give us a starting position already. So we're going to put SR and SC on our Q. SR, SC. Let's also grab the pixel color that they give us. That will be equal to image of SR, SC. We're also going to have a visited set. Okay, now all we have to do is run breadth first search on this. So we'll say, while the length of our queue is not equal to 0, what do we have to do? We will grab the row and the column with q.pop left. Okay, now what? Now we need to check and make sure that the row column pair that we just grabbed is not in our visited set. So we'll say if row column not in our visited set, what do we want to do? We want to check and make sure that the previous row, the next row, the previous column, and the next column are also within this grid. So if we're given this pixel right here, we want to make sure that the next row in the same column is still a valid value within our grid. So if we went 2 rows down, we're outside of the grid. We don't have a valid value. And we need to check this for both the row and column. So we will say if our row is greater than or equal to 0 and less than the length of our image, and our column is greater than or equal to 0 and less than the length of our image of the first row, what are we going to do? We are going to, first of all, add that row column pair to our visited set. So add row column. We are also going to add the next row, previous row, next column, previous column to our queue. So q.append the next row of the current column, q.append the previous row of the current column, and q.append the current row in the next column, and finally q.append the current row of the previous column. Now before we end this, we also have to, after we add this row column pair to our visited set, we want to change the given starting pixel to the color that they give us. So we will say image of row column is now going to be equal to the color that they give us. All right, now we can just return the image. We should have performed a breadth first search and changed all of the connected pixels to their correct color. So let's run this. We get one wrong test case, so what did I do? This should be, this is right, this is right. Aha, we also need to check, because we don't want to run breadth first on every single pixel, right? This is a 1, we don't want to run it on 0. We only want to run it on the 1s. So we have to say, and the image at our row column is equal to our starting pixel column value. All right, now if we run this, we should get the right answer. Yep, and we passed both test cases, so we'll submit. Perfect. Okay, time and space complexity. Time complexity is going to be O of n. We are going to have to traverse an n number of pixels, and our space complexity is going to be O of n, where our queue can grow to the a length of however many pixels we have traversed. All right, that'll do it for LeetCode 733.